I'm going to explain how a rectifier cabinet works. So this is our rectifier cabinet, and it is a Delta brand. So usually when we get our power from the SCDBD, let me show you how our SCDBD looks like. That's how our SCDBD looks like, and this is its wiring diagram, power diagram. So let me go direct to our to our rectifier cabinet. So this is our rectifier cabinet. As I have told you before, and this is our backup battery. So these are, let me first explain part by part. This is our backup battery. It is the one which gives us power in case in the absence of other main power. So these are our modules, and these are and these are breakers, as you see from up. So let me explain by part. When we receive power from our SCDBD, SC distribution board, it usually comes to our circuit breaker. As you see there, the word main. So from when it reaches our circuit breaker for protection, it comes and goes direct to OVP. OVP stands for overall voltage protection, and usually works as our surging protection device. So from there, it is distributed to these breakers, and these breakers each goes to each of these rectifier modules. So we have 6 modules. So this is 1, 2, 3, 4, 5, 6. Those are our rectifier module we have, and here we must have 6 breakers for protection. So we have breaker 1, breaker 2, breaker 3, breaker 4, breaker 5, breaker 6. Each one corresponds with each rectifier module here. So the use of these modules, as I have told you, the use of this module, it is to convert the AC power which we receive, either single or 3-phase AC power, from either 240 or 415 volts to DC negative 48 volts. Because at telecommunication site, we always use negative 48 DC voltage, and I'll explain to you why we use it on my next video. So from up there to power is directed to rectifier module, and after being directed to rectifier module, it is converted from AC to DC of negative 48 and is connected to and the output, some is connected to the bus bar of negative 48, and other it is connected to the bus bar of positive 0 volt. So the one which is connected to the negative 48 DC distribution bar, it is the one which supplies power to these breakers, and some power is taken to the batteries, as you have seen. So we have battery 1, battery 2, battery 3, and also there's another one for battery 4, and these are batteries. So that means each battery here have a circuit breaker. So we have battery 1, battery 2, battery 3, battery 4, and these are their breakers. So the other breakers which we are seeing here are for other service providers. So here we have M10, Airtel, and Savannah. So these are their bus bar. So another thing which I didn't explain here, it is when power it is from the main, it goes to surge protector for protection, and from surge protector with some power is distributed to the circuit breaker for each of these modules, and some is taken to RCB socket. So this is an external socket which we usually use. Then also some power is picked to these breakers. Some is for fan, these external fans. There is still power from there. So, and when you reach the rectifier cabinet, you always see this thing. So this is an inbuilt control. This is an inbuilt monitoring system. So this is a Garori system. It is always used at telecommunication sites to monitor the power flow, to monitor also other things at that telecommunication site. So this is the signal and alarm unit. This is where the signals and other alarms are connected from here to go to it goes direct to the monitoring monitor. So what I didn't explain is this part. So this part is for the solar side. So this telecommunication side is for hybrid. We have the power from the main, that is from the grid. We have another source from the generator. I'm going to show you the generator, and then we have power from the solar side. So from the solar side, the power, when it comes from the solar, let me show you the distribution board for the solar. Is this one. So that one is for the solar. So we have 1, 2, 3 solar panels. So when power comes from that side, it first passes the OVP, the surge protector of over voltage protection, and then these are the breakers. So since we had 3 solar panels, that's why here we have 3 breakers with also which are connected to surge protector or over voltage protection unit device. So we have 1, 2, 3, and they also have their module, charger controller module. So we have 1, 2, 3 for each. So when we get power from the solar side, just passes here from them to the surge protector, then to circuit breaker, and then it goes direct to to its module. So from the module, it also give us the negative 48 DC, which is also connected direct to the bus bar, which supplies power to these breakers for charging and other breakers for our clients. So in brief, that is how the power flows at the telecommunication side. So I wanted also to show you something small. Let me see if I'll get. I didn't get it. So I wanted to show you this. According to the way I have been explaining to you. So this is what I wanted to show you. It is for the power flow at the telecommunication side. So the bus bar which I was talking about, we always have these two. There's the 0 volt bar and also the negative 48 bar. So that's this one for the negative 48 bar is the one which contains power here. So there's something else which I wanted to show you. Let me see if I'll try to get it. There's something which I wanted to show you, but I'm failing to get it. So this is a wiring diagram according to what I have been explaining to you. But there's another wiring diagram which I wanted to use. So let me see if we shall get it. There's another wiring diagram. So it is here. Wait. So from this wiring diagram, as I have shown it to you, I'm going to explain these things part by part. So these are our modules, like these ones. So here in our wiring diagram, this one and this one are our modules. So we have modules at A101, A102, A103, A201, A202, A203. So they are 1, 2, 3 up, and also you have 1, 2, 3 down. So this is what they're trying to make. A01, A0, A1, A102, A103. So this is A201, A202, A203, according to our circuit diagram. So they show you that they produce they convert